Hello everybody, it's Jamie here at home Rewire Scotland. This is part 2 of the certification video. We're going to get into a lot more detail about what's on these forms, and I'm going to try my best to put it in layman's terms so that your typical homeowner might understand it. I won't get too technical, and I'm sure somebody will call me out on if I don't get everything spot on, so we'll try our best to keep it easy to follow and understand. Basically, this is your certificate. This is what you're going to get. On the front page, details of the client, details of the installation. Probably the most important part is design, construction, inspection and testing with my signatures there. So basically I'm signing for the design. We do a lot of rewires and we don't sit down and design them on paper, but what we do is we design the circuits when we're installing them, so we know that a certain type of circuit needs a certain type of cable and we know the routes it can take, etc. So we're designing it as we go really. The construction is how we do it, so the way we route your cables and the way we fix your boxes and stuff, I'm signing to say that I'm happy with all that. And inspection and testing is probably the important part. I'm signing at the end of the job to say that we've inspected it properly and we've tested it properly. So any callbacks, any comebacks, anything at all, I've signed for this job, it's my responsibility. We also make a note when we think it should be next inspected, and there's also a part here for any comments on the installation. So we'll get into page 2. Which is this one. We've got a description really of the supply characteristics, so we just make a note of certain things, what type of cable supplying the house, what size of cable it is, and we make sure that it's testing certain readings such as your external earth fault loop impedance and your prospective fault current. Other things like we make a note of what type of earthing system it is, we make a note if we've bonded your water and your gas. And then we move on to a schedule of items inspected. So this is an inspection tick list really we've got to do for every job. And it's things like here, the condition and adequacy of the distributor's supply intake equipment. So that really means it's got service cable, service head, distributor's earthing arrangement. We're really ticking those boxes there to say that the supply cable coming into the house is in good working order. The supply provided by the network provider is in good working order. We had an instance actually a couple of weeks ago where it wasn't. The earth wasn't sufficient, so we have to call them out and they have to rectify that. We then go through the rest of it, and it's just a big series of ticks. This is page 3, and it's just to say that we're routing the cables in the correct zones. We're using the correct type of circuit breakers, and a big tick list or a non-applicable. There's a part here for like special installations or locations, perhaps like swimming pools and stuff, so a lot of it doesn't apply to your typical domestic situation. From there we go into the test results, so this is probably the most important one, and most of the jobs we'll do will be a 10-way consumer unit, so you get 10 spaces here and then we fill that with circuits, so usually we've got sockets, central heating, lighting, cooker, shower, whatever. We make a few notes on the type of cabling. We make a note on the reference method used. That means how we've routed it, if it's going through insulation, if it's clipped direct on the wall, or if it's in conduit. We've got to mark all that down. We mark down the size of cables we've used. We mark down the type of circuit breaker we've used. A lot of these values are just repeated on our jobs. It's mostly the same kind of stuff we are doing. So from there we start our test. So we do a series of tests. I'll try not to get too technical, but we do insulation resistance. So basically that means you don't want any of your cables touching, such as live and neutral. If live and neutral are touching throughout your job somewhere, then there's a fault on it. And they don't need to be directly touching. They can just have a bit of resistance. They can have a path between them that is causing a bit of a connection there, and that's going to create a fault, and particularly from live to earth or neutral to earth or anything like that. If you've got any continuity between those cores, then you've got a problem. So insulation resistance, we'll fire 500 volts or 250 volts down that circuit, and that can tell us if everything's intact and there's no continuity where it shouldn't be. So that's an important test. From there we then do the continuity. So we will do the continuity of your circuits, and we need to make sure that, for example, the earth going from your consumer unit to the last light away upstairs is continuous the whole way. So we do a series of tests, R1 plus R2, or if it's your socket circuits, we often wire them in a ring circuit. So we've got to do the continuity of those cables. We just use an ohm meter, and it will tell me if that cable is continuous the whole way around, and it will tell me the resistance of that cable as well. So for example, if you use a twin and earth cable, you've got 2 cores in that and you've got an earth cable. The live and the neutral should be round about the same. There's a tolerance there, and your earth will be a wee bit higher because it's a smaller cable, so it's got a slightly higher resistance. So we can tell right away if your neutral core, for example, had a much higher resistance than the live, then you've probably got a loose connection somewhere on your sockets, which could potentially be quite dangerous. So it's an important test to make sure everything's continuous. From there we go into your earth loop impedance. So this is an important one, probably hardest to explain. Basically, if you have an electrical fault in your property, the current wants to flow to earth. So everything wants to flow to earth all the time, which is ground. We want to create an easy path for that current to flow, and we do so by providing an earth cable. So every cable we provide in your house will have an earth cable. And we want any fault current, so if there's a fault in that cable, we want that current to flow down the earth cable and nothing else really. So we measure that path, we measure the resistance of that path. The reason for doing that is if you've got to meet disconnection times. So if you imagine you're getting electrical shock for a metal appliance, you've got to meet a disconnection time of 0.4 seconds usually, which means if a fault occurs, that MCB, the circuit breaker, will trip out before 0.4 seconds or 5 seconds for over 32 amp circuits. So in order for it to trip out quick enough, the earth fault loop path has got to have a low resistance so that the current can flow quick enough. So if you had a circuit that was 2,000 metres long on about a 1mm cable, it might take a bit of time for that fault to clear from the end of that circuit all the way back through the consumer unit and away to ground, so it could be potentially dangerous. So we've got to check that the earth fault paths we are creating throughout the property all meet the right resistance requirements and comply. And those values will change massively between types of breakers used and different things. So it's just a safety reading really, and make sure it's the circuits are of the right kind of length and route. We go on to RCD testing. So you've probably heard of RCDs. RCD is a safety device that monitors the current, flow, and it will monitor any earth leakage. So if you had an external light that was getting a bit damp and there was some current flowing through earth, hitting a bit of water and flowing through the brick to ground, the RCD would detect that and trip out right away. So RCDs can become a bit of a nuisance if there's any earth leakage at all throughout the property. Even an old appliance might have a bit of earth leakage that previously wasn't shown up in the old installation, but now you get a super sensitive RCD there and it is shown up. So the RCD tests we do really just make sure that the RCDs are tripping quick enough, and we've got certain times that they've got to trip within. So we make a note of them, we do a test using our test meter, and it tells us if the RCDs are functional and if they're tripping quick enough. And that's really it. So that's all your stuff. We've got to make a note of the test instrument we use. We've got to put the serial number down, and this stuff is really, I mean, if an accident happened on a job, the first thing I'm going to do is come back to these certificates and I'm going to go, well, where's the instrument that was used? Let's get that. Let's make sure it was calibrated. Let's make sure the installers put the cables in as they said, and let's make sure the values that they've wrote here are accurate. And if they're not, then you could be in a bit of trouble, I guess. So that's your certificate. Every job we do, you'll get that. If that's of any interest of you, great. If not, and you just want a bit of paper to say everything's good, then that's what you've got. So that's your test results. Thanks for following that video. Thanks.